Well, hello everyone, and welcome to another episode with your girl, Audrey Codner from ACG Math Tutoring. Well, we're going to do something a little bit different. So, I am working on my next book. So, I like to do the flashcards, and I was noticing a lot of my kids were struggling with simplifying square roots, or AKA is really called a radical. So we have different types of radicals, and what I need, since we need to kind of do some content, because apparently TikTok is thinking that I just don't exist. Hey, isn't that lovely? All right. So if anything, you guys are kind of like helping yourself by looking at and try to retrieve on how to solve radicals, as well as you're helping me with possibly, is this a hard question? Does it need to be more challenging? And so forth. So even if you're just like, Audrey, I haven't seen square roots since I was a fetus, not a problem. Come on in, because I am still going to give you a problem. I want you to do whatever the interactive is, which right now we're going to simplify the square root of 50. And I'm still going to solve it for you, okay? I know we're so used to seeing multiple choice, but let's see if we can work on some of our skills. So, the square root of 50. I know there's going to be somebody that's going to give me a decimal. Oh, there it is. Because they're using their calculator. But they're not saying for you to solve it. They're saying for you to simplify it. So that means we want to keep it in its radical form. So we have to think of what are going to be the magical numbers that is going to help us break down this square root of 50. So I'm seeing some 5s, I'm seeing 7s, I'm seeing 5 and 2s, I'm seeing 5, the root of 2. Same thing that's going with Perla. Okay, for your eyes only is telling me 25. I'm seeing the square root of 5, square root of 2. And then now we got the 5 and 10. We got 5 root 2. Okay, so we got a nice little mixture here. All right, so let me show you how to break this down. And then we're going to rate this question because we're going to need to. All right, so now when I have the square root of 50, we want to break it down. I'm going to write it right on here because this is a sample. So when we break down that root of 50, we want to get what's called a perfect prime combination. So we want to get our perfect square here, and we want to get a prime number here. So both of them are still going to be rocking the radicals until it's perfect. So now we got to think of multiples of 50, or what that will give me 50. So I know that 5 times 10 will give me 50. That looks a little crazy. Okay, I know that 25 and 2, that will give me 50. And the normal 1 and 50. So which one would give me a perfect square root and a prime square root? So yes, we got our 2 and 25, 2 and 25, 2 times 2, yes. So the perfect will be my 25, okay? My prime will be my 2. Reason why the square root of 25 is perfect, because, let me whip out my cards, because I know that 5 times 5 will give me 25. And if I wanted to do the square root of 25, it's going to equal my 5. So that is a perfect combo. So that means the square root of 25 is just going to give me an answer of 5. But whereas the square root of 2, that's going to be prime because 2 is a prime number. The only way you can get it as a product is multiply 1 and 2. So since I can't break it down, I simply bring it down. So my answer will be 5 square root of 2. Okay? All right? So now I want you to rate this. Okay? Scale for, let's say, 1 to 5. Okay? 1 is like, good. Can't even put a word to it. Or 5 is like, wow, that was hard. and my mind is about to explode. 3 is like, meh, it's all right. It's all right. So go ahead and put that in there. Is it a 1? Is it a 3? Or is it a 5? Okay? Going with that nice, keep it easy and easy. So let's rate it, okay? So I got a couple G with a 1. Got you. Big G money. Giving me about 3. Okay, you're struggling with this on your GED test tree? I got you. All right? I'm going to say it's a 10. Okay, still confused? 41 years old? Hey, guess what? You're still young. Okay, you're younger than I am. I got you. All right, so about a 3 and a 4. All right, I could take that. I'll take that. Okay, I'm going to give myself a nice little score there. All right, so let's try this one. Okay, actually, I'm going to adjust my paper here. 1 second. There we go. So much easier. All right, so let's try this one. Simplify the square root of 75. Okay. Once you explain, you remember it? Yeah, I know. 1996? Yeah. Yep, I graduated high school in 90. Yes. Craziness. Perfect squares? I know, and that's fine. Taking your test Monday. Okay, well, guess what? Stay with this live, and I bet you'll feel confident by the end. We'll be less than an hour, okay? All right. All right. So what's the rule? So the rule, we always want to break it down into a perfect prime combination. So we need 2 square roots, okay, that multiply to give me 75. One of them is going to be perfect, so that means a number multiplied by itself, and the other one is going to be prime. Okay, what do we got here? I love it, like once I start doing math, everybody's like, I'm out. Bring your butts back here because you should be in school. Okay, not a problem. All right, so I'm seeing a lot of 25 and 3, 3 and 25, 25 and 3. We have 5 and 6. We have 5 radical 3. Thank you, Jen. Okay, we have like 5 and 15. True. All right, so let me list that out. So we have a 5 and 15. We have a 25 and 3. Okay, there were some other ones. Beautiful. I love this. You have your... Okay, 5 times 3 raised to the second power, which 5 to the second power, let me see if I can find my lovely cards. So if we know that 5 to the second power, that is the same. Oh, where'd my other thing go? Okay, 5 to the second power is not the same as saying 5 times 10. Stop it. It's the same as saying 5 times 5. And we all know that 5 times 5 will give us that magical 25. As soon as I can pull it out of my chart. Okay. All right. So 5 squared is equivalent to 25. But if I want to do it in reverse, if I wanted to find the square root of 25, that means I'm looking at 5 squared. And I know that squares and square roots, they cancel each other out. When they cancel each other out, they give us our 5. So the best one that will work for us in this case, yeah, 5 and 15 can work, but then I still have to break down the 15. 5 is prime, but 15 is not a perfect square because the only way I can get a 15 is 5 times 3. Whereas 25 and 3, 25 is a perfect square root because 5 times 5 gives me 25. The same number multiplied to itself gives me this 25. And that 3 is another prime number. So if we have the square root of 25 and the square root of 3, we can break down that square root of 25 to give me 5. And then we just break down, because if we can't break down the prime, we just simply bring it on down. So again, we have 5 square root of 3. Okay. All right. All right. So on a rating scale, 1, bleh, 3. Okay. No, I'm talking about the level of questioning, not so much your ability or how it was solved. Okay. The level of this questioning. Is it a 1, is it a 3, or is it a 5? Okay. So we got a 3, 4. Okay. Happy Thursday to you. Can't believe it's Thursday already. It's so crazy. All right, about a 3. All right, I'll take that. A 3. All right, I love the 3s. A 5, T Brown, I got you. All right, awesome. Okay, so I'm gonna rate that a nice little 3. I like the 3s. There's nothing too crazy. All right, so let's up the ante. Okay, so for people that are coming in, you're probably like, what is this? Well, 1, you're helping me create my next math book, okay? A lot of the math books that I currently have, which is called Algebra at Your Pace, it helps people that are struggling with algebra. Either they need it for their GED, the ASVAB, the ACCUPLACER, the TEAS test, okay? So I have my workbooks. But in addition to these workbooks, I have like resources. So there are some resources that deals with flashcards. Like say for this one, I have it for order of operations, evaluating, and substituting. So I have like solutions, I have like some of the evaluating pieces, I have some of the simplifying pieces, okay? And then also I have the order of operations, which are like usually in the back with all the simplified. So what you guys are doing for me right now is 1, helping me find another way to help you guys out, and 2, how to create it. Because right now, I'm tired of using my brain. Okay? All right, yes, the flashcards are the best things to help you improve the memories. A lot of people say, well, I could just do this on my phone. And I'm like, but dude, you use your phone for everything else. So your brain is just thinking like, oh, you're just holding your phone. So you're not going to be motivated to pick up your nice little stack of cards to kind of help you remember these things. So I'm seeing a 72. I'm seeing a 27. Okay. I'm seeing a 3 times 3 times 3. Okay. I'm seeing 3 cube root of 3. Okay, and there was probably some other ones earlier, so let me flash up. Okay, so someone's saying the answer is 3. I have 3 root 3, not sure. I got some 9s. I have some 3s. All right, I love how we're getting this. We're getting multiple answers, and this is what's telling me that, yes, Audrey, this is needed. All right, so now we have to switch our brain in a moment. So we are looking at what's called a cube root. So now cube roots are basically numbers dealing with the inverse of my cubes. Let's say if I said 1 cubed is the same as saying 1 times 1 times 1. So if I wanted to do the inverse of my cube, let me take this away. The inverse of my cube is a cube root. Now here's the thing about radicals. The exponents and the roots, they cancel each other out. They're inverses of each other. Okay? Cube is the inverse of the cube root and vice versa. Just like how squares and square roots are inverses of each other. And if you're still like, what's an inverse? Think about addition. The opposite of addition is subtraction. They're inverses of each other. Vice versa with subtraction with addition. Same with multiplying and dividing. So if I cancel those two lovely things out, I'm going to get my wonderful answer of 1. But we need to think of a number that could be multiplied to itself 3 times to give me 81. Now, I know right away based off of some of the answers, some of you guys said, oh, the answer is 9. But you're thinking of the square root of 81. Okay? The square root of 81, that is 9 squared. So they cancel out, which will give me 9. Because 9 times 9 gives me 81. But we're looking for a number that's going to multiply to itself 3 times. And I'm going to tell you, it's definitely not 9. So now some people are saying, oh, well, let's do 3. So we got 3 times 3 times 3. 3 times 3, that gives me 9. And 9 times 3, that gives me 27. So in this case, 81 is not a perfect cube. It's a perfect square. So this is telling me if I multiply 27, if I just, and of course it's so cold here in Maryland that a lot of my pens froze over. Can you believe it? So I'm just ravishing, trying to grab as many pens as I can. If I multiply that 27 by 3, let's see what we got. 7 times 3, that gives me 21, carry the 2. And 3 times 2 gives me 6, plus 2 gives me 8. Ooh. So something is telling me if I did 3 to the 4th power, that would work. But we need cube. So this is what we got to do. Let's split it into 2 different cube roots. We know that 3 times 3 times 3, that's the same as saying 3 cubed. So we know that 3 times 3 times 3 gave us our 27. So I'm going to put the 27 down here because this is a perfect cube, which the cube root of 27 will give me my 3. But then, in order for it to equal to 81, we have to multiply that 27 to another 3. Okay, that's what we're doing. We're splitting things up. So I know 27 times 3 gives me my 81. The cube root of 27 is 3. But the cube root of 3, we can't break it down. The reason why, 3 is a prime number. So since 3 is a prime number, we can't break it down. But we can sure as heck bring it down. All right. Okay. So we can't give any decimals. If they say simplify, you can't get a decimal. Nope, they don't want decimals. It's not even going to be an option, no matter what test you're looking at. It's not going to be an option for the SAT, the ACT, the GED, the ASVAB, the ACCUPLACER, the TEAS test, the HESI test, any kind of test that you want that has to deal with algebra. You're going to have to learn how to break it on down, okay? So this is why we really have to do. That's why I know a lot of people are like, just use a calculator. Trust me, babies, if I could just have to use a calculator, we wouldn't be having this live at all. I'll be sitting there downstairs, ready to eat, I don't know, something, and just calling it a day. But this one, since 81 wasn't a perfect cube, this little index right here will tell you what kind of radical you're dealing with. If you don't see anything in this spot, that means it's assumed to be a square root. There is no such thing as a one root, okay? There's only one band, one direction, okay? But there is no such thing as a one root. So since we had to find perfect cubes, that's why we really need to understand what are my perfect cubes. So, I think I have it for you. So my perfect cubes, we have 1 is a perfect cube, okay? Because 1 times 1 times 1 gives me 1. 8 is a perfect cube because 2 times 2 times 2 gives me 8, all right? So where's my, I got everything like all color coordinated. I thought I did. Don't you love when you think you were organized? Okay? So if you're not believing me, 2 times 2 times 2. So that means 2 times 2 gives me 4, and 4 times 2 gives me 8. So 8 is a perfect cube. 27, that's a perfect cube because we have what? 3 times 3 times 3. We just saw that, and actually is peeking in. Let me move that over right over here. Well, all those words are in the way. Okay, so 3 times 3 gives me 9. 9 times 3 gives me 27. Then we have our 4 times 4 times 4. And I know right away people are like, oh, it's 16. Nope. 4 times 4 gives me 16. But 16 times 4 gives me 64. All right. Okay. So those are those things. So now rate this problem for me. Is it 1 that it was, is it 3? All right, that was a little bit challenging, but definitely able to do it. Or was it a 5? Like, yes, put it in the book. Definitely. Giddy's like 6. Is saying 5. Yes. Evo is saying 5. Okay, 3s. We got 5s. Easy. All right. Okay. Got 5 from Donald. Got D with a 5. Okay. No crying, D. It's okay. It's okay. Okay. This is just kind of solidifying that these are some of the things that I need to create for you guys. All right. Al's with the 5. Kathy with the 5. Chris Rock with a 5. All right. Thank you. So I'm going to put my 5 right here. Definitely adding that to the mix. All right, next one. Okay, hopefully you guys are enjoying this. I don't want to like torture you. Sorry, I'm feeling like I'm treating you like guinea pigs. But hey, aren't we all a guinea pig if you think about life? But here we are. So we need to simplify this. So this time we have 2 times the square root of 3. Times 3 times the square root of 2. Huh. Okay, you're learning. Awesome, Kathy. I love it. Okay, just did this with your 13-year-old, but it was all perfect squares. Yes, usually with the 13-year-olds, they'll be just working on the perfects. Yep. Now, if you want, you can always, I have these cards. I already have these cards. I have a book ready for them. So if you ever need all your perfect squares and cubes, I just cut them out and laminate them. Just let me know. And actually the link is in the bio underneath my math resources. Yeah, so right now I'm not with TikTok Shop at the time, but one day soon. All right. So as we're taking a look, what do you think? That's root 12 times root 16. Is it? Okay, we got 6 root 6. Okay. And if you are looking at some of these and you're like, Audrey, question mark, I don't know. You can put a question mark in the chat. That's perfectly fine. That's completely legal. Okay. Yeah. So if you ever want any of these cards, I have like my roots always from 1 to 16. I just printed up to 12 for today. Then you have the squares. You can do like a matching game. Okay. So then you have all of that to 12. And then I have all my perfects. So if you ever need those, you can just look up, that's all in one book. And you can do it either digital or you can have paperback. But let's see, okay? Thank you for the honesty with the question marks, guys. I love that. I'm seeing 18 times 12. Okay, is that Shani? We have like 216. We have 6 root 5. We have 6 root 6. And this is why, hey, Lynette, how are you? We're going to have to meet up sometime soon. Maybe after this live. Love it. Thank you so much for using the lovely little stickers that I have. You barely passed high school. I have no idea what's going on. Don, that's all right, because you didn't have me as your teacher. It's okay. All right. So let me tell you the whole tea with all this. 1, when you are multiplying with radicals, you can only, especially for multiplication, always take a look in between the parentheses to see if you are multiplying. Sometimes they slip a little addition or minus sign in there. You can only combine whole numbers with whole numbers and radicals with radicals. So if I want, which I will, if I want, all of this is multiplication. So if I want, I can group my 2 times my 3. I like to use parentheses so it doesn't look too crazy. And then my square root of 3 times my square root of 2. Just so I can have a nice little grouping. You can only combine like with like. So when you multiply the 2 times 3, which gives me a 6. And then you multiply the square root of 3 with the square root of 2. Your answer is still going to be underneath a square root. So 3 times 2, that will give me 6. Okay? So all of this is multiplication. All right? So when you multiply the whole number with the whole number, you cannot multiply a whole number with the radical. It's almost like, I don't know, how should I say it? Like some people like to eat their food separate. I'm like this with ice cream. I love fruit, I love ice cream, but not put together. Put the strawberries on one side, the ice cream on the other side. Okay? I'll eat the strawberries, don't eat the ice cream. I don't know. Maybe I'm something weird, but that's what I do. You can get them close together. They can touch. I'm not that crazy. They can touch, but I don't want them to mix, right? So you have basically your whole numbers, okay? Everything outside the radicals multiplied together, and then multiply together what's inside of the radicals, okay? Now, for addition, I just want to make sure, I want to make sure I get that clarified. For addition, the radicals have to be exactly the same, and in which that is supposed to be the second question, which I'm going to show you. Okay? So my answer for this is 6 radical 6. All right? Okay? The other problem, not so much, but you're getting this one treat. All right. Hey, I still call it success. Okay? So for this one, what are we going to rate it? 1, 3, and 5. 1, super easy. Like, get over it. 3, yes. Put it in the book, Audrey. I think that'll be good. There's a nice little transition. Or 5, oh, hell yeah. What we got? Okay, you can go in betweens as well. All right, so I got some 1s, I got some 4s, I got some 5s, I got some 5s. The hardest is the 5. The hardest is the 5. Okay, my feminist is like 0.00001. Okay, we got our 5s, we got our 3s, we got our 1s and 3s. It's tricky. Okay, so I will take that as a 3, definitely. 5! All right, and with 3, is that grasshopper? I was saying 3, okay. Why you're not multiplying 2 by the root of 2? Because they are not the same. They're not considered what like terms. You only multiply whole numbers with whole numbers and radicals with radicals. That's the only association you do. Yep, this is definitely not FOIL. Okay. All right, no FOIL method here. No. All right. All right, so I'm going to say about a 4. Looked like around that thing. All right, thank you. All right, so let's see the difference. Let me jump ahead. I had another problem ahead of it, but, we'll jump ahead. All right. Okay. Tears. I know, right? But it took me a while to feel comfortable with math because I used to suck at math, like hated math, cried every night. I was that kid every single solitary night. I was the kid that people would put me in a corner. This is before we had special education. I was in a Catholic school, so, the nuns were serious. So they'll just pull you into a corner, give you a whole bunch of problems to do, and while they continue on with the class, and there was no discussion. That was me. So, hey, after practicing and finally someone saying to me, hey, fractions is nothing but division, it just clicked. And now here I am. I'm a math teacher. Good God, who did that? All right. Yeah, so it was all kinds of crazy. So here, again, we're going to simplify. we have 2 times the square root of 5 plus 7 times the square root of 5 minus 3 times the square root of 2. Ooh, what is going on here? I know, I'm teaching it now. Isn't it crazy? What's happening? Oh, thank you so much for the rose, Jeanette. Thank you, thank you. Thank you so much for tapping of the screens and everything. I love that, guys. Thank you. Yes, please let TikTok know that I exist. For heaven's sakes, I was so close to my 40K followers. All of a sudden I look today, they took 300 people away. Maybe they were just fake accounts. But it was so sad. It was like people just left me. I felt abandoned again. Anyway. Okay. Oh, thank you. You exist to me. So yeah, just make sure I'm not a figment of your imagination. Because that might happen. All right. So let's take a look. Okay. This time we have addition, we have subtraction. So if you notice, anytime you have addition or subtraction, you can only combine with like terms, meaning they have the same radical. All right. Oh, thank you. So welcome on to the mathletes. So since this has a square root of 5 and this has a square root of 5, I can go ahead and combine what's called the coefficients, the numbers that's in front of your radicals. So what I'm going to do, how I'm going to combine them, I'm going to follow the operation that's splitting them up, the addition sign. So all I have to do is add 2 plus 7, which last time I checked gives me 9. Hold on. 7, 8, 9. Yeah, it gives me 9. I'm just kidding. But believe it or not, I still tutor. I tutor in addition to this. And I still have a kid that counts on their fingers. Hi, senior in high school. Just want to put that plug out there. All right. Now, what's going to happen to the square root of 5? Since we are adding, we're just going to drop it down. Okay. We are not adding the radicals. No. All right. We're not adding the radicals. All we're doing is we're adding the coefficients. Boom. That's where the 9 came from. And since they both had the same radicals, you're bringing it down. So it's almost like, all right, I got 2 vanilla wafers over here. I know I've been craving sugar. It's just me. Plus 7 vanilla wafers over here. Well, guess what? That means I have 9 vanilla wafers together. Okay. Notice I did not do anything with the wafers. I just counted how many I had in this pile, how many I had in this pile, how many is going to go into my belly. There you go. So now we have this minus 3 square root of 2. Well, these are not the same radicals. So since they're not the same radicals, guess what? We're done. That is it. This is your answer. I wish I could use the rest of my other Sharpie pens, but they are frozen. It was 7 degrees this morning. I swear to you, I do not live in Greenland. Why am I trying to survive? My poor house is just trying. It's trying its best. Right? So that's it. Okay, this is done. Oh, you're there? Right. Only go that far. That's okay. This was tricky. Okay. No, it's not wrong. You can't go any farther than that. If it is wrong, tell me, Flexi. How is it wrong? Go ahead. Ready. Yeah, 7 degrees. Crazy. Insane. You can. We'll do it. Why can't we simplify more? Okay? Why can't we simplify more? We don't have the same radicals. Remember, this was 9 of the vanilla wafers, right? This is, 3 chocolate chips. If I have vanilla wafers on one side and I have chocolate chip cookies on the other side, you can tell I'm hungry. Again, craving sugar. How can I take 3 chocolate chip tickets? Here we go. Chocolate chip cookies away from 9 vanilla wafers. Not the same blessed cookie. Okay? Still delicious. No nutritional value whatsoever. All right? So you're breaking... Who's breaking up with me? We're done? Oh. We were in a relationship? What was that? Okay. Oh, 42 degrees? Oh, Miami? Are you all right? Put a sweater on. You'll be fine. We'll love 42. Oh, my goodness. All right. Oh, bring in the 9. All right. So they're not the same thing. Okay. So since they're not, so I would love to do bold colors, Queen. Would love to. But here's the funny thing. Ready? My pens are frozen. Like literally. I'm surprised I have these. That's all I got. This is it. And then I found this one was giving me somewhat life. That was it. That's my life. Oh my gosh. Yeah, so we're done. That's it. We can't break up the 9. The 9 is not under a radical, so that's not giving you a 3. The 3 is not under a radical, so we can't break that up. All right? Yep, it's 22 degrees right now, but still. Well, no problem, Queen. I'm sorry. Just losing my mind. It's been a day. It's, you just pray to God and you're just like, all right. Okay. Okay. Are you guys going to send me markers? That would be so cool. Let me give you my Cash App. Hold on. Because I love how everybody's like, oh, just bring markers. Yeah. Okay. Wait, I forgot. What do you think? A 1, 3, or a 5? What do we got? What do you think? Ugh, I know. 22. Seriously, in Brooklyn. Taking pre-calc right now. This is so helpful, refreshing. Oh, good. I'm so glad I can help with the refresh. All right, so Kathy got 3. Kate Garas Haba saying 3. Nana saying 4. Okay. Determine square root without a calculator. Well, good luck with that. That is just not my jurisdiction, especially not in my mindset right now. Okay, so we got some 3s, we got some 4s. All right. So what if it was all addition? Even if it was all addition, if they do not have the same radical, they cannot be combined. Okay? All right? They cannot be combined. Does that help you, Tree? Okay. Is there a schedule for my lives? No, there isn't. I keep trying to put a schedule together, but when I get a client that says they need me for tutoring, I have to go. Okay? All right, so I'll say about like a 3 or a 4. All right, I'll rate that right there. Okay, so now let's try this one. Let's see if we can get this one. I know I'm flipping all over the place, but again, I just want to see what we'll be dealing with. So again, we're going to simplify. We have the square root of x squared y to the 3rd. What age do I tutor, Miss Donna? I go from 7th grade all the way up to adults. So for some of you guys that are trying to get your GED, your ASVAB, your ACCUPLACER, your TEAS test, or maybe you're going and actually you did very well with your ACCUPLACER, but now you're in college algebra and you're like, ugh, what is this? Or you're decided to take the statistics class. Okay. And I've been helping people with that as well. Okay. All right, SATs. Sometimes I do SATs. I haven't been getting a lot. Well, I think I haven't been getting a lot yet because it's not February, and the next SAT is March 14th. So I think a lot of people are just kind of waiting. Do we just times the exponents? Ooh, Tree, you're kind of close. Kind of close. In your calc final? Yep. But see, here he goes. 6'2". The difference between... Well, that's not too bad. Yeah, because sometimes a lot of people are like, well, I got this on my final. I got this on my test, which is good. So SAT math is so easy. For some people it is. For a lot of people it is not. It's just a matter of how you are reading the test. And then you're doing your process of elimination. Okay, so we got some xy's, 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 xy's. We have x times root 3. We have xy to the 5th. xy with a root of y, or root of y. Okay. All right. All right, so 57 out of 58 questions correct. Awesome. Good job. Do you factor out? You could. All right, so this is what we can do. Remember I said earlier, if you were here earlier, that we're dealing with, if you don't see an index right here, that means we're dealing with a square root. So square roots and squares basically cancel each other out. So if I want to, I could put them in their own radicals. Okay, so if I put them in their own radicals, maybe if I zoom up a little bit, that might help. So for the x's, my x squared and my square root, they're inverses of each other. So they cancel each other out, leaving me with x. But it's hard to do that for the y's because I have an odd exponent. So here's one way that we can do it. And there's multiple ways of doing this, right? One way, and I'm going to put it over here, if I wanted to break down root 3, or square root of y to the third, I can split it up, like almost like the factor tree. And what I do is I always pull, if it's an odd number, always pull one of that variable out and then subtract from the 3. So that means I have 2. So if I have 3 originally, pull 1 out. That means I have 1 less, which is 2, because 2 plus, remember there's a 1 that's understood to be there, will give me my 3. Now, you have an even amount. So squares and square roots, they cancel each other. So what's left from here is a y. Now this square root of y, that's prime because it's to the first power. It can't be broken down any further. So if you can't break it down, you just simply bring it down. So now, since this is all multiplication, put them all together. So that means your final answer is going to be x, y, square root of y. Okay. Okay. So, this is one way of doing it. All right. Another way, especially when you have an even root with an odd, because basically what you're doing is you're really dividing the index with the root. This is a square root, so it will be a 2. This has your exponent of 2. 2 divided by 2 will give me 1. X to the first power is also known as just x. If I tried to do 3 divided by 2, 3 divided by 2, that's going to give me 1.5. No. So what we can do is pull out, just like how we did here, pull out one of your y's so you can create an even exponent over here. So if I have 3, I pull 1 out, that means there is 2 y's left. So if I want to, a square root with an exponent of 2, 2 divided by 2 will give me 1. Oh, there it is. Y to the first power is also known as y. And then that square root of y that we just pulled out, we can't break it down, we bring it down. And then you just put them all together. xy means x times y, square root of y. All right? Okay. All right, you love it, you love it, you love it? Okay, so let's rate it. Yes, exponents, man. I believe if you know your multiplication tables inside and out up to 12, okay, you can do any math possible. Okay, if you understand your exponents, that will be helpful as well as order of operations. If you can knock those 3 things down solid, you can do any type of math. You can manipulate numbers any type of way that you want to make it work for you. All right? But let's rate it. 1, 3, or 5. 1 being hell, no, gross. 3, it was challenging, maybe, but okay, you can put it in your book. Or 5, like, put it in the book. Okay? If you want to go with a 4, I would take a 4 as well. Okay? I was just passing by. You made it look so easy. Oh, well, thank you. 10 for sure, Chris. Okay, Lubes. Got with my 4. Okay, 6 for feminist. Go ahead. All right. Yes, Elena with the 5s. All right, got 3 for you. Will be good for others. Thank you, TikTok Garage. Appreciate that. Mew saying 10. Got it. All right. Awesome. Love that. We're definitely going to put that in the book. I'll say like a 4 or 5. Definitely in there. All right. So here's another one. Got a few more before I have to skedaddle. All right. Ooh, what's this? Okay. I do try to make it look easy. Thank you, Linda. I appreciate that. User 21 saying yes. Awesome. Okay. All right. I understand now because my brain doesn't work whenever it's math. I know. See, right now you got that trauma, Matthew. You have that trauma. And it's a matter of now you got to remember, you're not that little kid in the classroom, was afraid to ask questions, wanted to look cool, just did what everyone else was doing, even though you're thinking that you were running things and you really wasn't, because there was always some big girl or big boy that said that I run things and you're like, yup. Yeah, been there, done that. All right. Okay. So let's take a look. So we have the square root of x plus 4. So that x plus 4 is underneath that radical equals 5. So I got a couple of people with 21. I got 21, 21. All right. Brian Matthews with 21. Okay. You with 21. Pitch Black 21. Oh, Dr. Manuel 21. Okay, so Violet, I'm saying 26. With T, we got 21. Violet's with, she's holding true. It's 26. Okay, we got 21, 21, 21. Band, I don't know. Hey, thank you for your honesty. I greatly appreciate that. Okay, Africa Coolest Man, got 21. All right, so there's a battle between 21 and then Violet is holding true to her 26. She's like, look, I'm holding on to this. Okay. So Captain with 20, Kathy's not sure. Thank you so much for your honesty. All right, so let's take a look. So we are trying to get x by itself. Right now, it's inside with my plus 4. But we need to get rid of this radical. So take a look. There's nothing there, so that means this is a square root. I have to do, when you're doing solving, you're doing the inverse. So the inverse of a square root is a square. And whatever you do on one side, you must do on the other. So that means this square and this square root, boom, they're done. They cancel each other out. So now I got my x plus 4 equals. Now, 5 squared. 5 squared is not 10, okay? 5 squared is the same as saying 5 times 5. And 5 times 5 equals what? 25. So here we go with our 25. And now we want to get x by itself. So we have to do the inverse of plus 4. So the inverse of plus 4 is minus 4. Okay, so now we have our x. We don't need to bring that 0 as a placeholder because we had that x on that left-hand side. And now we got 25 minus 4. That gives us 21. Okay. All right, so are we good now? Okay, we good? Good. Can do the first file. Okay, so rate this question. Is it a 1? Ugh, just stop. A 3? Yeah, I was like, okay, this will be good for the book. You know, I can see it being helpful for somebody to ease them into it. or a 5, like, hells yeah, put that in that book, girl. Okay. Yes, you were right with the 21. Okay, good. Inverse rules. Everybody's doing the opposite. Simplest, okay, we got some 5s, we got some 3s, got some 3s, okay. Wrong, okay, spell wrong correctly, and then we can talk. There we go. Okay, so you foiled. All right, awesome. We can do that. Body, 2 or 3. Okay, garage. I got you, TikTok garage with a 4. Okay, how did I get the -4? So you always do, if you want to cancel, if you want to isolate this X, you have to do the opposite of the signage of this number. So the sign was a +4, +4. So the opposite of plus is minus. Okay? So that's how we got that -4. And whatever you do on one side, you have to do on the other side. Okay? Why do I post simple questions like that? Because everyone is not on the same purpose. Some people are on the same line, some people are not. Okay? You will fail your, oh my gosh, why were you going to fail it? What is this mindset? Change that. Okay? Why the 2 on top of the 4? Because that's a square, Alex. The opposite or the inverse of a square root is a square. And you don't put the 2 next to the 4. That's for us to cancel out that square root. And whatever you do on one side, you do on the other. Okay? Once you cross the equal sign, it changes. What changes? Oh, okay, I see what you got. I see what you're saying. All right. Okay. Hey, not a problem. All right. How would we rate this? Okay, we had some like 5s, we had some 3s, a couple 4s. Okay, I will say, mostly people will say like a 4 or a 5. I will accept that. This is going to be a big, thick book. All right, so let's try this one. I'm going to see if I can do 2 more, and then I'm going to have to leave you for the rest. Maybe I might come back on tonight. We'll see. Not making any promises. We'll see. Hopefully my pens will dry out by then. Remember about gel pens freezing. That's funny. All right, so now we're going to solve. We have the square root of x minus 3 plus 2. Now, this plus 2 is not underneath our radical. All right, so you got the square root of x minus 3 plus 2 equals 6. We are solving for x. What do you think? So we got a couple 19. And rubbing alcohol? All right, I'll give that a try, T. Brown. This is solving radical functions. Okay, this is solving radical functions. RADICAL functions. Okay, so I'm seeing some 19 is 19, not 2. Okay, got you. All right, couple question marks. Thank you so much for the honesty. So I got a 5, I got a 1. All right, got an explanation. Do you have to multiply each side with the other side of what number you do? Okay, let me show you in a moment. Okay, we multiply to get rid of the radical. That is going to happen. Okay, so I got some 19s, I got some 4s, I got 7. I was wrong. Get me my pen and paper, try to do it in my head. Okay, all right, so Amy, hey Amy, is saying, thinking it's 5. Got you. Yep. All right. Definite mixture. Hello, Bobby. Bobby's thinking 37. So let's take a look. Okay. Now, let me see if I can find that other one. Okay. Now, when we did this one, we only had the radical on one side. So immediately, once the radical was isolated, we squared both sides. Now, this time, we got this plus 2 in the way. We need to isolate this radical before we do any squaring. So the first step is we need to subtract 2 on both sides. That's our very first step. The reason why we're doing that is so we can isolate that square root of x minus 3. Okay, we had to isolate this. Now 6 minus 2, that will give us our 4. Okay, so now we can do the square of both sides. Okay, do we all see that now? Because based off of some of your answers, a lot of people just went ahead and squared everything. Okay, but we need to isolate the radical first, then we square it. The reason why we're squaring it, because this 2 and this square root will cancel each other out. They are inverses of each other. So now we have x minus 3 equals. Now we have 4 squared. Now, 4 squared, where are we? Oh, where'd my 4 squared go? My 4 squared escaped me. All right, we'll figure it out. So with our 4 squared, we know that that is 4 times 4. And 4 times 4, that will give me my 16. So now we want to solve for x. So what we need to do, we have that minus 3. We have to do the inverse of minus 3. So the inverse of minus 3 is a positive 3. So these will cancel out, leaving me with x. I'm going to bring it over here because I ran out of room. Okay, we don't need to bring the 0 down as a placeholder because we still have x on the left-hand side. And then 16 plus 3, that gives me 19. So my answer is 19. And if you want to check it, 19 minus 3 will give you 16. The square root of 16 is 4, and 4 plus 2 does give you 6. All right. Yep, I got you, Bobby. I'm going to see if I can squeeze it in there. All right. So how you feel about this? Is this a 1, a 3, or a 5? Okay. 1, 3, or 5. Let's rate this problem. Should I put it in my book? Sorry, crazy puzzle pieces. Okay, definitely 5s, 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 5s. Just 5s. Okay, BB1. Don't put it in. Why? Is it because it's hard? Because you do need to have challenging problems. You will see a problem like this. Maybe not the exact same problem, but you will see a similar problem like this. GED, SAT, ACT, ASVAB. Okay? There's always going to be a question. It's too easy? Okay. All right. The majority will kind of give me like an average of roughly like a 4. In, out, in, out. All right. Okay, so let's try. All right, yeah, I'm getting close to time. Okay, so let's try this one. This will be my last one. Okay. So we're solving. We have the cube root of 2x minus 1 equals 3. What is the value of x? You see a problem like this and realize I work in construction? Believe it or not, Dylan, I don't know. Did you have to pass the IBEW? Because they had a question like this and slope. Lots of slope, lots of equation lines, lots of graphing in the IBEW. Because I helped a couple people with that. Okay. Never too easy. Okay. So I'm seeing some 5s. I'm seeing a 14 from Sarah. I'm saying 2. Kathy, not sure. Thank you so much for your honesty. Hey, Z, same 14. I didn't see you sneak in here. Okay, we're not rocking with the cube root. Yes, we are. Okay, guys, switch our brain around to kind of hover over those cube roots. Okay, don't worry, I got you. Just here to learn. All right, diamonds, welcome on in. Yep, the cube root threw you off. It always does. It always does. That's why I'm trying to do like a nice little mixture. Okay. Kathy, I was bad at math. Yes, and you know what, Kathy? I love how you said was. Thank you. Okay, you're still alive. God has given you a purpose. You got a pulse. You can still do math. You can still do these things. Okay. All right, so I'm seeing Bryce with 13, Bill 13, Ryler 7, Lulu 14. Okay, Amy with a 14, Vass with 14, Pitch 13, Brenda with a 1, TikTok with an 8. We got a lot of numbers here. We got a couple 14s. Nanish, how are you? Okay, Mike with a 12. All right, Andy with a 14. All right, you changed your answer. Okay. All right, so we are dealing with a cubed. Okay, we're dealing with the cube. Now, just like what we did, I'm coming back to this problem. When we noticed that our index was a square, a 2, because we don't have anything like a 1 root. There's no such thing. That means we have to square, right? So square root, we square. Guess what we're going to do with a cube root? We're going to cube. So that means we're going to raise this to the 3rd power. And whatever you do on one side, you do on the other side. What's going to happen here is this cube and this cube root are going to cancel each other out. So what's left is my 2x minus 1 is equal to 3 to the 3rd power. Now, 3 to the 3rd power, people, it is 3 times 3 times 3. Okay, so 3 to the 3rd power is not 3 times 3. Okay, if I can find it. Hurry up, Audrey. Okay. All right, so 3 to the 3rd power. That's the same as saying 3 times 3 times 3. Now, 3 times 3 times 3, 3 times 3 is 9, and 9 times 3 is 27. Okay, so 3 cubed is not 9. Okay, this exponent is telling this base you need to multiply yourself 3 times. So now we need to do the inverse of minus 1. So we're going to add 1. So that gives us our 2x is equal to 28. So if we divide by 2, that means our x is 2 divided by 2 gives me 1. 8 divided by 2 gives me 4. So x equals 4. Okay. All right. So, gotta skedaddle. This was fun. Oh, wait. Rate this problem before I do anything. I might do another one of these later on this evening. I think I might be doing it with rational functions, or I might even finish up the ones that I have here with the radicals. I don't know. It's going to be a fun. All right. So we got some 5. Seems easy, but the day of the test, forget everything. So like a 5, a 1. No problem, man. Not a problem, Alex. You're so welcome, Grasshopper. No problem. So 4s and 5s. All right. So we got 5s. You learned. Yay! There we go, diamonds. That's what I'm saying. Learn something every single solitary day. Love it. Okay. So like basically like a 4 and a 5. I saw a couple like ones like, oh, this is easy. But my whole focus, I'm going to be truthful. I love people that are currently taking this in class, but I tried to reach a lot of students that haven't seen math since they were a fetus. So, And I really want them to, if they do not have their GEDs or if they just need assistance with math, that was the main reason why I do a lot of these books. It's just easy for me to show it this way. So the name of the series is called Algebra at Your Pace. Right now I have volumes 1 through 6 available on the A. If you want, the link is definitely in my bio. But what we are working on, okay, I was working a lot from my squares and my cubes books. These are my other reference books. So if you look at the link and when you finally click on, it's like, oh, you're going to another person's link. Yeah. But if it says math resources, this is what I'm talking about. So I have a book on order of operations. I have a book on squares and cubes. I have a book on verbal to algebraic. So if word problems is your part that you usually suck at, this is the one for you. I have a book on exponents, a book on the formulas that is going to be used on this test. Wouldn't it be nice for you to have like a matching and an answer key so you can make sure that you're studying correctly and that's not going to give you a weird explanation that you're going to be like, what the hell did I just look at? That's going to help you out. I try to keep things nice and light and simple. One of my students yesterday actually even said, Miss Audrey, I'm going to do it your way because your way makes sense. Well, my teacher goes a little too crazy with stuff. But at the same time, listen to your teacher. Then you have the algebra. If you need any of the resources that you're going to need for algebra, everything from basic integers, even factor charts, that's all going to be in here to help you with your factors, multiplying integers as well as dividing integers. So all of these are made for you. If you want them, the link is definitely in my bio. You just go ahead and click on it. Make sure you follow me here because you never know. I might be able to come on tonight, probably finish the rest of these things up, or I'm definitely going to be coming on tomorrow because tomorrow's Friday. I can't believe it. It's just so quick. And I usually come on Fridays. I think it's going to be early afternoon, probably like around 1. All right. So if anything, hello, AR, how are you? So if you need anything, go ahead and message me. Follow me, message me. If you want to become a fan, that's awesome. You don't have to be a super fan. I'm perfectly fine with that. Have fun with the stickers. I'm just here to support, but thank you so much for your time and attention. And I will see you possibly later on tonight, but if not, definitely tomorrow. Okay, so make sure you follow me so you know when my crazy behind comes back on here on live. All right. Pray for me because we only got 4 more days of this. And then we can have a balmy of 27 degrees on Monday. All right. So have a wonderful day. Unfortunately, I won't be able to do any lives and put them on my other channels because they're not downloading. I don't know. I'm just here. All right, guys, I have to go. You guys stay blessed up, and I will talk to you guys soon. All right, bye now.